The topic we're learning here is dividing complex numbers, but I'm going to actually start by talking about multiplying complex numbers, and I think you'll see why in just a moment. So I'm going to start by multiplying these together. This is 1 minus 3i plus 3i minus 9i squared. I always change I squared to negative 1. So I have 1, and then this turns to positive 1, so I get a 2. And notice what happens here. I have negative 3i and positive 3i. They cancel. So my answer would just be 2. Let's look at this one. This would be 4. This would be minus 2i plus 2i minus I squared. I squared is negative 1, but I have opposite of negative 1, so that really becomes plus 1. So I have 4 plus 1, which is 5. Negative 2i, positive 2i cancel. So my answer is just 5. On this one, 5 times 5 is 25. This is minus 10i. This is plus 10i. And this is minus 4i squared. The 4i squared turns to negative 1, so that really turns to plus 4. So I have 25 plus 4, which is 29, and the negative 10i and positive 10i cancel. So take a look at that for a moment and see what you notice. Probably some of you noticed right off, and as we were going, the answers turned out to be just a number. When I started off multiplying two expressions together that had I ended up with an answer that had no I. So what makes that happen? If you'll notice in the problem, I have 1 plus 3i, 1 minus 3i. Here I have 2 plus I, 2 minus I. 5 plus 2i, 5 minus 2i. So the number in the front stays the same. The back number stays the same. The only thing that changes is the sign in between. So because the sign in between changes, that's what makes these two terms cancel out. These two expressions have a name. They're called conjugates. So for instance, if I had 2 plus 7i, the conjugate of 2 plus 7i would be 2 minus 7i. If I had negative 3 plus I, the conjugate of negative 3 plus I would be negative 3 minus I. Conjugates are going to be helpful when we get ready to divide. So let's start our first division problem. Example 1, 5 plus 3i over 1 minus 2i. The problem with this problem is that it has an I in the denominator, and nothing is ever simplified when you have an I in the denominator. So I have to find a way to get rid of I in the denominator. So I'm going to do this just like I did with radicals. I'm going to multiply by the big one, the well-chosen one. I want to pick something that will get rid of I. Well, we just found out up here at the top, if I wanted to get rid of I in a problem, I could do that by multiplying two conjugates together. So down here, I want to multiply by the conjugate of what's on the bottom. So since this is 1 subtract 2i, I want to write 1 plus 2i. And since this has to be 1, I have to put the same thing on the top. So now I'm ready to multiply. On top, I have 5 plus 10i plus 3i plus 6i squared. And we're going to take care of that I squared by turning this into negative 1, which in turn will really turn this whole thing into minus 6. So the numerator is 5 plus 10i plus 3i minus 6. Okay, let's look at the denominator. 1 plus 2i minus 2i minus 4i squared. And we know that I squared is negative 1, so that turns this whole thing into plus 4. So on the bottom I have 1 plus 2i minus 2i plus 4. So let's put our like terms together. On top I have 5 and negative 6, that turns into negative 1. 10i and 3i is 13i. On the bottom, the positive 2i and the negative 2i cancel. That's what I wanted to happen. And then I just have 1 plus 4, which is 5. So this would be my answer. I know I'm finished because I don't have any imaginaries in my denominator. Let's do another example. Here's example 2. 3 plus 11i over negative 1 minus 2i. I want to get rid of the I in the denominator, so I'm going to multiply by the big one. And the big one is going to be the conjugate of the denominator. So since this is negative 1 subtract 2i, I'm going to make it negative 1 add 2i. So here's what I've got. On the top, I have negative 3, I'm just distributing, plus 6i minus 11i plus 22i squared. And I know this is negative 1, so this is really going to make this minus 22. On the bottom, negative 1 times negative 1 is 1. This gives me minus 2i plus 2i. That's good. These are going to cancel. That's what I wanted to happen. Minus 4i squared. I squared is negative 1. So this turns into positive 4. All right, let's put our like terms together. On top, I have negative 3 and negative 22. That's negative 25. Positive 6i, negative 11i is negative 5i. And on the bottom, 1 plus 4 is 5. Here's what I notice about this one. Do you see how every number in here is divisible by 5? So I can actually reduce this one, and this is why. If on top I factored out a 5, I would get negative 5 minus I left. And on bottom, I just have 5. So when you have a factor on top that's the same as on bottom, they will cancel. So the answer to this problem is just negative 5 minus I. Okay, I want to do 2 more examples with you. So here's example 3. 2 minus 7i over 1 plus I. If I were you, I would pause the video and try this myself. Okay, hopefully you tried it yourself. We're going to multiply by the big one. Since this is 1 plus I, I'm going to multiply times 1 minus I. So on top, I have 2 minus 2i minus 7i plus 7i squared. We know that this is negative 1, so it's going to turn this into minus 7. So I'm going to go ahead and get the top put together. 2 subtract 7 is negative 5. Negative 2 subtract 7 is negative 9i. All right, on the bottom, 1 times 1 is 1. This turns to minus I plus I minus I squared. So these cancel. This is negative 1, but I have the opposite of negative 1, so this really is a plus 1. So on bottom I have 2. Since 2 doesn't go into both of these numbers, I cannot reduce. Last example. 4 plus 5i over 2i. So again on this one, I want to try to get rid of the imaginary number. So I'm going to multiply by the big one. Now, on the bottom, the only thing I need to get rid of is the I. So this could really be like 0 plus 2i or 0 minus 2i. So really the only thing I need to multiply is by 2i. So on the top, I get 8 plus 10i squared. Oops, should be 8i. On the bottom, I get 4i squared. I squared is negative 1. So on the top, I have 8i plus, 8i minus 10. And on the bottom, this turns to -1, so that's -4. Well, I notice that there's a number that goes into all of these numbers, and that number is 2. So I'm going to factor a 2 out of the top, and I'm left with 4i minus 5. And I'm going to factor 2 out of the bottom, and I'm left with -2. So the factors of 2 are going to cancel. So my answer is 4i minus 5 over -2. Delta Math may ask you to write it like this, -5 plus 4i over -2. This would be a perfect answer. They may ask you to go ahead and make these, take a negative out, and if they do, it would be +5 minus 4i over +2. These would both be correct answers, and I think they'll both be accepted.